Hi everyone, welcome back to day 4 for Java lecture. I'm your Gaurav here and today we will learn about the OOPS. But I hope before I begin, I just want to confirm one thing with everybody. Have you watched the previous lectures? The day 1, day 2 and day 3? Because anyhow this is day 4, right? So you need that previous information. So where you can get that data. Today anyhow I will cover these few concepts. Also one new concept which is super keyword. But I just want that, did you get the content for day 1, day 2 and day 3? If you haven't, then search Prepensta, go to the playlist and you'll find it. Okay, you will have Java for placement in 7 days. Okay, and again, if you want to learn aptitude, refer this playlist, and for DSA, refer this playlist. Perfect, yeah. Cool, awesome. We'll go back. Now here, the first topic that we will understand today is the what is OOPS, then class and object, encapsulation, inheritance, runtime, and compile time polymorphism. Then we'll do some level of practice. Okay, so here I have one topic which is intro to OOPS. So what is OOPS basically? It's an object-oriented programming style. Okay, object-oriented programming style. So now the thing is, really, I have one story to tell, and that will learn with the help of that story. But anyway, what does it mean? If I ask you the simple meaning of this, you'll say like something is like where we'll drive everything with the help of objects. That is true only. So object-oriented programming style is something where you do everything with the help of objects. But object of what? Object of the class. So class is nothing. Okay, class is nothing. It's sort of blueprint. Okay, class is nothing. It's sort of blueprint. So blueprint means basically a structure, like how you want to store the data and how you want to use it. So that's a structure where everything will be, you know, added. That's a blueprint. Let's say whenever you create a home, now you have a structure, you have a map, you have a blueprint. So similarly, class is a blueprint, or right, where you'll put every data or you will have a complete structure. So class is nothing; it's just blueprint. We'll understand now. With the help of examples, you'll have more clarity on this. Just blueprint. But what is object? So object are the instances of the class. Instances mean they will reference to the class, and only then object can only work with the help of uh, classes only, right? So object are the instances of the class. Instances of the class. So that's what the object is. Okay, so we will understand, for example, you know that we were using a scanner class for taking the input. So scanner was a class while we were creating a scanner SC, so that SC, like scanner SC is equal to new scanner system.in. So that SC was an object. So whatever we want the functionality from the scanner class, we were having with the help of object only, right? And all the functionality were defined where? Within the scanner class. I hope now you're getting some point. So now here I'll come back again. So what is oops now? Which means that everything, whatever I'll do now, that will be derived by the object, which is clear to me. Now, what are the other pillars and fundamental thing? So there is a one good keyword. We call it CUAPI. CUAPI. So C basically for class. Okay. E basically encapsulation. Here I'll just erase this thing. I guess encapsulation. Here I'll take a pen. Encapsulation. O for object, A for abstraction, and P for polymorphism. Polymorphism, and again I for inheritance. So what I've written here now, I've written all the 6 important fundamental pillar of the object-oriented programming style of the OOPS, basically. So these are the 6 fundamental pillar of the OOPS. COAPI, class encapsulation, object, abstraction, polymorphism, and inheritance. So we will learn about all of them. So now you know what is class and object, right? You have that idea. What is class and object? So class will be a blueprint, object will be the instance by which we can like put or access right anything from the class, right? Something like this. So I'm just giving an example. Let's say I don't know, yeah, next time probably I'll use somebody's name who will put the comment, a good comment. But let's say this time there is a Mohan, one person. Okay, I'm assuming he's a class, so Mohan is a class now. Who will be the object? The friend of the Mohan. So the friend or any relative. it must have a relation, right? It must have a relation. So only this guy can do anything with this class, right? This guy can do anything. Let's say this guy wants some data, it can take some data, right? Or let's say Mohan is having some cold drink, so this guy can also take the cold drink, samosa, or I don't know what all, right? Dosa, idli, whatever it will, right? So because this is friend, so friend will access whatever the rights it will have, right? It will access accordingly. So that's what the object is. That's what the object is. Object will perform all the operations, right? And all the thing whatever we need from the class, we'll do with the help of object only. I hope making sense somewhat the sense, right? Making sense now? Awesome. So now here, what is encapsulation? Encapsulation. So now here I just want that you should understand one thing. What do you read? What do you read? So you'll say, sir, I'll read capsule. Capsule. Capsule means what does capsule looks like? So capsule is something like this. Very bad drawing, huh? Very bad. So here you have multiple medicines within this. Yes or no? In capsule. So what you're doing, you're wrapping up multiple property within a single unit. Right? Wrapping multiple property, multiple properties into single unit, yes or no? Into single unit. That's the encapsulation. You getting my point? You're getting my point? That if I have multiple medicines now, I have wrapped all of them into a single capsule. So that's the encapsulation. Okay, so how do we define in Java and what are the use of this getter and setter? So basically, remember when we were learning in the last lecture, we were learning access modifiers. There we learned about the private. So private was something which was only associated to that particular class, right? You cannot access it outside the class. That was a private property. So which means that whatever you're putting, that is wrapped inside this particular class only, inside that particular unit only. But now if something is private, how will I access and how will I update it? That is my question. Right? That is my question. How will I access and how will I update it? So you will access with the help of getter functions and you will update with the help of setter functions. You're getting my point? You will have getter and setter functions. Those will help you to update and get the value from the encapsulated class. Okay, if you have something private property, then you need getter and setter. That will do in the practical also. So let's go to the VS code that will define a day for, right? If I have somewhere. Yes, you remember this was the code of the last day, day 3. Today we'll create another folder which is day 4. Day 4. I'll move within day 4, cd day 4. So now I'm in day 4 and here I'll create one file. The file name is, let's say, uh, I'm just talking about encapsulation, right? So I'll create an encapsulation dot java. Awesome. I'll just remove this package I really don't want. Or you can have some package, okay, if you need, in case. So now I have this thing, public static void man. This is a basic template which we used to do, right? Which we used to write. So now here the thing is I want to perform an encapsulation. So basically in this encapsulation class, you can have any other name also. Okay. You can have encapsulation example or something. You can have any other name, whatever you want. You can have any name. Okay. You can have any name, whatever you want. That's not a problem. Awesome. So here what I'll do is now, here I'll create some variables. So let's say I have variable, a private variable, and I call it name. Okay, I call it name. That will basically store the string. So data type is string. The variable name is name, and I put a value. Let's say Gaurav, which is my name, right? Gaurav Pandey, somewhat. So I have written this thing. Then I want something else. Let's say I want private. I want, let's say, something. mm, what do I put it here? Let's say company. But here also I need a category which is string, or I'll put company equals to, and here I'm writing preference star. Okay, so that's what few two details I have. I just want to access them here. Okay, I just want to access them here. I'll do south. I'm writing name here. It's saying like cannot access, cannot make a static reference to the non-static field name, right? The thing is, if this was static only, then you could access it. But this is not static, so you cannot access it directly. What you have to do, you have to create an object. You remember? This is a class. Look at it, this is a blueprint. This is a blueprint, right? Everything is inside this. And now you need an instance of this class to access the property of it. So now I'll create an object. And how will you create an object? With the help of class name. So you put the class name, which I have written encapsulation here. Encapsulation. Here you put the object name, let's say obj or something, and here the new keyword, with the new keyword only you create the object, and here encapsulation. Done. Now if I want to access with the help of this obj dot name, oh not pbj, it's a obj. Okay, so now I'll try to run this. Okay, so c java c, the file name is encapsulation.java. Now Java, I put encapsulation. So now you're getting Gaurav Pandey, right? You're getting Gaurav Pandey. Why? With the help of object you can access. With the help of objects you can access. But what if you have another class, then you want to access? Then you have to use getter and setter. That we will understand. Okay, let time come. Okay, let time come. Then we will understand when you need getter and setter. But these are the methods by which you can access and update the value. Basically, they will provide you the more security. For example, I'll create a method here. Let's say public method. Public. That method, let's say, won't return anything, or it will just print it. Okay, or let's say it will give you the name. So I'll return a string. Return type is a string. The method name is my name. Okay, and here it does not contain anything, and it will return, basically it will return what? It will return my name. Okay, so it's a getter method. How? Because this is returning something value, so it's a getter method. It will help you to get my name. It's a getter method. Awesome. Then what is setter method? Setter method to update. I'll tell you why they are needed. Okay, I'll tell you why they are needed. So here I will have setter method. Setter method, basically that will update. So here I will have public. Let's say here, should I return something? Should I do have to return something? So let's assume that I have to return something. Okay, and returning type, something should be what? But let's say I'm not returning this time, so I'll put void here, and the method name should be, let's say, set name or something. Set name, and basically this will have one name automatically containing in it. So let's say new name. I'm creating a parameter here, and what eventually will happen now? Whatever the name I'm having as of now, that will be updated by new name, and that's why we're not returning anything. So what eventually is happening here is now we're updating a name. So I'll show you how this is working. So here I'm printing my name, right? And here, what if I do this set name? So I'll do obj dot set name, and here I'll put the name, let's say uh, men, Gaurav Bhaiya. Gaurav Bhaiya. So now if I run this, what name you will get? Think about it. What name you will get? You're having Gaurav Bhaiya. Having what? You're having Gaurav Bhaiya. Why? Because of this new name which you put it now has been updated with the help of this set name. But also now few people will say, sir, also I could do in this way. Obj dot name, I could have written here something else. Right? I could have written something else here. I'll just make the comment of it. And now she'll say now that will come something. So look at this, it's coming something. So why do we need this getter and setter? Now you know that how you define it, but why do you need it? Time will come, don't worry. Time will come, then we'll tell you why do you actually need them. Okay. Awesome. So now here we know getter and setter are the methods which are used to get and set the values. Right? More securely. Securely why? Because nobody knows. Here, what was the variable name? What was the variable name? Look at this. Nobody knows that there was a variable name was name. If they are not developer, right? If they have code only, then they know everything, right? But let's assume some client is using your application and backend you have written this thing. So nobody or somebody is trying to access your backend service and front end. They will never know that you had a variable as name. So protecting the more security, right? And again, you're encapsulating everything into one single unit, which is a class. So this is an example of encapsulation. This is an example of what? Encapsulation. Example of encapsulation. Awesome. Now next topic. Okay, now next topic, we'll understand get and set still they are in pending. Another topic is inheritance. So what is inheritance? And have you ever heard about that we have been evolved from the monkey to human, like this format? So what actually changed in every generation? So I will say, obviously, the how do we look that has been changed, right? According to the weather, according to the climate they were having over the time period, right? Or the places, the geography where they're living, right? So that all these things impacted, but how they came into the genes. Also the thinking power. Today people those are thinking like they will not learn. So in brain you have a gray matter that will not increase. If you will not solve the problems, you will not use your brain. Gray matter will not increase, which means the future generation will have less IQ or less logical thinking. Okay, so that's the inheritance something, which means that whatever property I'm getting today, na, some of the property are coming from my parents. That's the inheritance, right? I'm inheriting some property from my parent. So child is having some property from the parent. That's the inheritance, basically, right? So what means in OOPS basically? So let's say if I have a class A, okay, and class B. Here I have some properties. So if this class we want to use the property of all the property of class A, then it have to inherit it. So what you how do you inherit with the extends keyword? Extends what? Class A. Class A. So now eventually what will happen? This will become parent and this will become child. This will become child, this will become parent. And all the property which belongs to class A will come to class B. Okay, so now if you create the object of class B, you can access all the property of class A. Getting my point? That's the inheritance. So let's understand this also. Okay, let's understand this also. So now what I will do now, I'll just make an example, the same example of the encapsulation also, and for the that inheritance also. Okay, so for example, I had this class, right? Then I will have another class. So I put this class and package somewhere. I'll create a package here. Okay, I create a package. So let's say package name is oops this time. The package name is oops. Why? The declared package oops does not match the expected package day 4. So let it be. Do not match. I'll compile it. So Java C hyphen D dot means the directory, the same directory, and the what I'll do, I'll compile this file. Encapsulation dot Java. Eventually, what happened here is that we are having the oops. We are having a package which is oops, and within this oops, we are having another class. Right? We are having another class. Making sense to you? Correct? Right. Awesome. So now the thing is, what I will do is now, basically I have, let's say I'll assume I'll just delete this thing from here, move to trash. So now somebody will ask, sir, how will I run this now? How will I run this? Because my file is available in the oops. So you have to do this thing. Java C, then that package name dot the file name. Oops dot encapsulation. Now this is running fine, right? So that's how you run. That's how you run if you have packages. So now I'll create another file here which is inheritance. Inheritance dot Java. Okay. So basically this is inheritance, and here I will have a package which is oops. Okay. I need to import it. I won't write it. I'll import it. Okay, I'll import it. So import oops all the classes. Why this does not import? Import oops cannot be resolved. Let's figure out why this is not importing it. I guess I'm in the correct place. So here import hmm, hmm. Yeah, it should use it in this way. Why it's not coming? Day 4 dot oops. Probably now this will work. I guess we are within this day 4 package, and then we have the oops package. That's why maybe this was not coming. So anyway, now what we'll do is now we have this class, and what I will do here is that basically I have this class, and here I'll have man method public static void man, and now in this method what I will do now, I'll just define some methods. Okay, I'll define some methods. So let's say here I'll define a method, method or variable something, anything. So let's say I have a string variable, a string, and we can say like topic or something. I don't know what we want to put, but I'll just put something. Okay, so this is inheritance, something like this I've written, and here I'll print it. South, and here I'll print topic. So now eventually, the thing is, what is happening here? Oh, why this is not giving? Cannot make a static non-reference. Oh, so I have to make the static. Otherwise, I have to create an object here that already, right? So now if I run this now, let's see, is it running or not? So Java C, the file name is inheritance.java. So it's compiled, does not exist. That's not, I guess. Oops, also it will say the same thing. No, that worked. I don't know why my BS code is suggesting something like, but anyway, this worked. Okay. So now Java, I run inheritance, and here we go. Okay, so this is inheritance. This is inheritance, which is coming as of now, right? So what if I want that? I want to import the feature of the encapsulation class. So then what I have to do now? I have to extend it, and that extends known as inheritance. I want to extend what? I had a class encapsulation. I had a class encapsulation. Encapsulation. And where it is? It's available in the oops package. It's available in the oops package. This is for all. This is for all. So either you have a specific or you have all. So I have all. So now the thing is, I'm having this package, right? I'm having this package. Now, after this package, I'm having this class. So what eventually will happen now? This become a parent class. This become a child class. And all the property of encapsulation, now I can access it here. I can access it here. So what you have to do, you have to, like, again, if you create the object this inheritance class, now you can access all the property of this encapsulation class also. So I'll create an object of inheritance class. So inheritance, the class. Okay, the object name I'll give, let's say obj equals to new inheritance. And now if you have the object of inheritance class, you can access all the property of encapsulation also. Okay, so now here basically what I will do is now, here I'll try to access obj dot, I guess what was the name is, I guess my name something I had. Correct. I guess that was returning or it was printing. What it was? So it was returning, so I have to print it here. I have to print it here. So I'll put it within the south. Within south, I'll put south, and then I'll put this thing. Correct. I'll put this thing. I'll just show you how this looks like. Okay. So I'll compile this inheritance again file. What does it say? Cannot find symbol. Here it's saying to me cannot find symbol. Obj dot my name. I guess that was the name, na? If you remember, that was the name of that particular class. Here somewhere we had that same thing, right? Public string my name, and it says that it does not have. If that extends, then automatically I should get it. If that extends, automatically I should get it. Correct. So here it says obj dot my name method. You don't have variable object of type of inheritance. Symbol method my name cannot find symbol. Why it can't find the symbol my name? If we have that method, let me check here somewhere. Inheritance thing. Why this is not coming? My name. If the properties encapsulation is available here, it should get it. So I have this inheritance. My name. Makes it appears correct sub directory or subpath. Maybe because of this is not imported properly. That's why. Encapsulation. Let's do it again. It's happening maybe because of. Yes, now this is working. I guess especially class we was not getting. I was thinking like this is correct concept. Why this is not working? So the asterisk was not getting it, but now this is fine. I guess I haven't compiled what last time. When I was doing all, it should work. Okay, that should work also. Sometimes the correct concept gets the confusion. So I compiled it again. Okay. Especially I have to when I put the class name here, then this is working. All is not working somehow. But that's fine here. Because of importing thing, it was not working, but now this is working fine. So now eventually what is happening here? What is happening here? We're getting this data. We're getting this data, right? This inheritance we are getting. Look at it, my name. But now if I want to access that private thing, can I access? Can I access the private variable? You remember? Let's try. We remember? I told you the use of getter and setter. Encapsulation, whatever you had in this encapsulation class, that is now the property of the inheritance. So if you create the object of inheritance, you can access all the property of encapsulation. Make sense to you? We had that thing. For what? We had that particular thing for that this particular method was available for the encapsulation only. But we are creating an object of inheritance and we are able to access it. And this is a feature of inheritance. Okay, this is the feature of inheritance. So let's say there was another property which was private name. Can I access the name here with the help of object? I could access there, but can I access here? Right? Can I access here? That is the thing. Okay, can I access here? So let's see. South. Here I'll put obj dot name dot name. So what does it say? It says it's not a variable. Why if I run this now? Because that was a private property and you cannot access it directly. So I write Java C. Look at this. What does it say? Name has a private access in the encapsulation. So now the thing is, if you have something privately available that cannot be accessed outside the class, that you already know, right? That you already know. But how will you access it? If any property is private, you will access with the help of getter methods. Getter methods. So now if you cannot access it, then definitely you cannot update it also. So then you need setter method, right? So here, what are you using? Using getter method to access what? Private property. Private property. Correct? Private property. And now how will you set it? How will you update it? So let's update my name. So what I'll do is now I'll come here and I'll update my name. So obj dot. I guess there was a property set name here. I'll put some name. So let's say Gaurav Bhaiya or something. Okay, Gaurav Bhaiya or something. So in this case, now this will come as Gaurav Bhaiya. Why you have updated this, right? Because that was a setter method which was public. So private property cannot be accessed, but if you are having a get and setter methods, you can access them. Look at this. It's coming as Gaurav Bhaiya now from here, from this place. Right? How this is happening? Because of the concept of getter and setter. So I hope now you understood inheritance. We can access all the property of encapsulation in inheritance. How? With the help of this particular thing, what we call getter and setter and the inheritance. So inheritance means that you will get all the property of the parent class to the subclass or to the child class. That's what known as this encapsulation thing. Okay, perfect, perfect. So now I hope the encapsulation is quite clear to everybody, inheritance is quite clear to everybody, and get and setter is clear to everybody, right? Now the another topic, runtime and compile time polymorphism. So what is polymorphism? Here polymorphism means having multiple behavior. Polymorphism means having multiple behavior. So multiple behavior means, let's say there is a boy. So in front of his parents, he behave like a child, like a son, right? Or in front of teacher, he behaves like a student. Or in front of his own children, he behave like a father. So in different situations, he's having different behavior. That's a polymorphism. Polymorphism having poly means multiple behavior. Like, समझ रहे हो? You getting my point? That if a particular method shows different behavior in different situations, that is known as polymorphism. You have two type. One is runtime, one is compile time. Okay, so now we will discuss the polymorphism. I hope the meaning of the polymorphism is quite clear to everybody, that when a method behaves differently in different situations, we call it polymorphism. And how will you define it? How will you define it? So we'll create another file here. The file name is, let's say, polymorphism. Okay, dot java. And here I'll just remove this package. I really don't want, otherwise I have to define it. Okay, so now here what I will do is, basically I'll have public static void man. And now here I have two methods. Okay, and we'll discuss about the compile time polymorphism first. Okay, compile time polymorphism. In this, basically two methods will have same name but different parameters, maybe different in terms of data type or maybe in terms of number of parameters that you have. That's known as compile time polymorphism. So here we will have two methods. So let's say public method, one method, let's say add, and it will return, let's say, nothing. It won't return anything, so I'll put void here. And the method name is add. Here we have two variables, int a comma int b. I have two variables. Now the thing is basically I'll just print it. Okay, so south a plus b. Okay, now here I have same method, the add. Okay, I'll just copy the same thing. Right now, if I put this in the same way, it's showing me error. But what if I change up one variable and see? Now it won't. Now it won't. Why? Look at this. You had only add method, but here he's having a different situation that the number of parameters are different. So it will behave differently. It will behave different. It's adding three elements, right? Now similarly, what if I copy this and I have different data type? In this case, what will happen? So here, let's say this is float type. So you can change the data type of all or of one. Then this is different. This is different. So now this is compile time polymorphism when you have a method that is having the different number of parameter or what the different type of parameter. So that will be a polymorphism. Look at this. We have only add method, but that is behaving differently. So now if I call my add method, so I have to create an object to call them because they are non-static methods. So I'll create a object. How? The polymorphism, the class name, the object name, let's say the obj or something, you put anything. It's up to you. Name then polymorphism, I put it here. Okay, I put it here. So now here what the thing is, we have polymorphism, and here what I'm doing is I'm just doing this thing. Okay, and now I'll call these methods. So I have obj dot add. So I'll put two values. Let's say 2 comma 3. Okay, 2 comma 3. So I put a two value. This will behave differently. I'll put obj dot add. I'll put the three values. This will behave differently. Right? Why? Because you have different number of parameters. 2 comma 3 comma 4. You're getting my point? So this will behave differently. And the last one, which I have obj dot dot add, which is having a float value, that will behave differently. That will behave differently. So let's say I have here 2.5 comma uh, here I'll put some value, let's say 4. I'll put some value, let's say 8. Okay, but what does it say? The method int in the polymorphism is not applicable for the argument double. So the problem is here is it's not able to recognize. So we have to put a different value or somewhat we have to define it. What I'll do is now I'll define it here especially. You have to tell that what kind of value you're passing. Now this is fine. So we're passing a float value. We're passing a float value. So explicitly we're defining because it's not able to recognize automatically. So now we're passing it. And how will it differentiate that it's a string like integer or not? So that's why you have to differentiate this thing. Awesome. So now if I run this now, Java C polymorphism, not Java, Java then polymorphism. Okay, so now if you see now we're having different outputs. Why? Why? Because it's a polymorphism. We had only add method. But different parameter or different type of parameters. So that's known as compile time polymorphism. But what is the runtime polymorphism? That is another question. What is the runtime polymorphism? So runtime polymorphism can be seen in the inheritance concept. So let's say I have another class. I'll define a class here. I have another class. So let's say parent class. I'll give a name to it. Parent class. Okay. And in this parent class, I have few methods. So let's say add method I have there also. Okay, the same add method I have here. Look at this. The method I'm having here also and the method I'm having here also. But now if I extends to parent class. Now eventually what will happen? You have one parent method here. Okay, and I'll say here I'll give a message. Okay, this I'll give a message south. Or I'll give a message directly there. I don't have to write this thing. I'll give a message here only. Okay, I'll wrap them in bracket. Oh, not them here in this bracket, and I'll close it. Okay, perfect. So now here I'll give a message plus. Okay, I'll give a message. So let's say I'll say sum from parent class. I just want to show you how this works. Okay, parent class. You have to put the focus. Only then you will understand. And now here I'm having the sum from the child class. Okay, so that's what I'll do. Sum from the child class. That's what I will do. So now sum from child class. So child class. So what happened eventually is that all the properties which parent was having, this polyfill is also having, but they are duplicated. Look at this. Here you also have add. Here you also have add. So now if you create the object of parent class, then you will access this. Then you will access this particular thing. Okay. So now I'm just showing you how this is working. I have the object of polymorphism class as of now, right? So now this time what will happen? You will have from the child class. I'll compile it, I'll run this. So now look at this. Sum from the child class. Think from the child class. How whoever is coming last, that will have the higher priority in the execution of the code. This is coming last. So why? Because this is child, so child will have more power. Child will be more powerful, and that's why it will override. Okay, so this also known as this runtime polymorphism. Okay, it has happened. What's happening here? This is happening runtime polymorphism. Here I'll just remove it. because now we are giving a different example. I'll put it here, and now here this is runtime polymorphism. A runtime polymorphism, and we call it method overriding. Method overriding. Why this is method overriding? Because you're overriding a same method which was available in the parent class. And here this is known as method overloading. Why? Because you're changing just the parameter. Method overloading. This is known as method overloading, and the runtime polymorphism is known as method overriding. I hope making sense to everybody. Help me out in the chat, huh? Help me out in the comment that is this making sense to everybody? Is this like oops concept is getting clear to you or not? I just want to hear here. I'll be really happy. So now here I hope this is making sense, right? So here what happening is that what if I want to access my parent class? What if I want to access my parent class? Okay, in this case, what you can access, what you can do is now, if you want to call it right here, you can call it's up to you. That what if you want to call this method here? So you can, obviously you can, right? It's up to you. Then you have to put a super keyword. You have to put a super keyword. So super keyword basically will call the thing from the parent class. So now here, yeah, but from after object, how will I? That other thing, I cannot use it directly here because that's object based. So maybe from here, super dot add. But now this won't allow me. Cannot resolve a type. Right, that is a problem. But how will I do this? So if I want to use this now, so I have to use a super thing. I have to use a super keyword. And if I want to access this thing right here, then I have to use a super keyword. So let's say for some time, what I want is now I'm just making a static, public static, and you will have example. Static, I'm also making it static because whatever you have in the parent, you have to give the same here, static. So both of them are static. So you don't have to create an object for accessing this add. You don't have to create object. Why? Because they are static. They're static. Right now, if you call this will come from the child class. From the child class. But what if you put the super dot add? Haha. Cannot use super in a static context. That is also the problem. If I want to use this now, I have to use a super keyword to access the properties of the parent, right? Not the child. So that is the use of super keyword. But here I can't because of the static thing also. But where I can use it? Hmm, if I want to call this somewhere, let's say somewhere here I want to call that particular thing. So in that case, I can use super dot add, and here I want to call something. Let's say 5 comma 6. But here I do not have access. Right, cannot use super in a static context. Oh, this is already so that thing. I have to remove this static thing. I have to remove this static thing. Super is basically when you want to give the priority to parent class. That time we call it super. So right now you cannot access directly here, but now let's see what's happening here. Obj.add. So here when this child class we're adding super.add. So basically we're calling this method. Okay, we're calling this method. Or you can else what you can do is now I'll just do this thing. I'll call here. But how will I call it here normally? That was the problem. I have to call it somewhere within this method or somewhere here, right? Without man method. Basically, this is for the variable of methods only, but I don't have any variable here, but I'll define the variable to tell you the another example. Don't worry. So I'll put Java C, Java. Now look at this. Both are executing, some from the child class, some from the parent class. Why is this happening? Because you're adding this super. Super basically referring to the parent. This is referring to the parent. So I'll just remove from here. And now I'll define a variable here. Okay, let's say I have variable here. A variable int a is equals to 5. Okay, and also in this child class I have int a is equals to 6. Now if I do this thing, south, oh not here, I cannot do this. If I do this thing here south, somewhere here south, so now or within the method, okay, within the method also, within the method. So let's say what I'm doing is now, okay, the variable here a and b also I'm having, I'll give a different name. Let's say this is e variable, okay, and this is also e variable. Now we have two variable, but I want to add something. Okay, I want to add something. So here I want to print something. When somebody call it console dot log. Oh, not console. It's not Java. It's a Java. It's not JavaScript. It's Java. Working in multiple languages sometimes gives us a challenge, which you've just seen. So now here, if I write E now, eventually what will happen? This will called 6 you will see on the screen. Java C, and I'll call Java. So 6 you will see. Why? Because this is coming from the child. Child will have the more preferences. But when you put the this thing, when you put super keyword here, super dot E, then which means that you're referring to what? You're referring to the parent class. Now you will have five. Now you will have five. Why? Because that's coming from the parent class. So that's the use of super basically. Whenever you want to give the priority to your parent class property, you use the super keyword. Okay, use the super keyword. I hope making sense to everybody, right? And how this polymorphism is working. And this is what is happening a runtime polymorphism because you had the add same add. Which one will choose? Right, the child one. But if you create the object of parent, then directly you can access it. That will work normally. That will work normally. Okay, I hope the polymorphism is clear to everybody. This add was behaving differently with different parameters, right? But when it comes to the parent and child, it behaves differently. That's known as polymorphism. I hope making sense to everybody. Now the thing is, another concept is abstraction that we will understand the next lecture. But I'll tell you the something. Abstraction is something when you hide the all longer details, you just show the important thing whatever they needed. That's the abstraction. That's the abstraction. For example, if you have a car engine, in that car engine what is important? You just important that how this works, right? Like, is it important that you need to understand how fuel is converted into the kinetic energy and this is working? No, I just want the functionalities. I just want the functionalities. In this case we use abstraction. So whenever we highlight the only important working things, right, and we hide the unnecessary details, that is known as abstraction. But in the next class we will understand what is abstraction, what is interfaces, right? But here also I just want to tell you one more thing here. If I have time, you guys, you do not put the comment there, which is really bad. At least I will know that what level of knowledge you have. Here right now, if you want to perform multiple inheritance, you cannot have multiple inheritance, which means that you cannot extend here multiple classes altogether. By putting the comma, you cannot extend multiple classes, right? So that is not possible. Then what is possible? Multi-level inheritance is possible here. Multi-level inheritance, which means that if you have, let's say, one class here, um, let's say I had a class, I'll give a class name here. I don't know. So I'll put a class name IDK. Okay, IDK. I don't know. And here in this class, I'm having a method. Let's say public. This method is having, let's say, a hello method. It will not return anything. So I'll put void and I'll let hello method. And here just a hello message. Shout hello from IDK. Okay. Now the thing is, what if I extend encapsulation here? Extends encapsulation here. Okay, so eventually what is happening is IDK is having encapsulation of what? Encapsulation of, like, this is having inheritance from the encapsulation class. And here you extend at the place of encapsulation, you can extend this thing IDK. IDK. So now eventually what is happening? Tell me what is happening here. This IDK is having encapsulation and inheritance is having IDK. That's a multi-level, label by label you can have. But all together you cannot have. All together you cannot have. That's what I'll just run the Java inheritance file. Java C inheritance dot Java. And now look at this is working fine. Now I'll execute it. Java inheritance. Now look at this is working fine, right? This is working fine. But if you want to call this hello method, you can call here. You can call here from the object of inheritance class. You can call here somewhere obj dot what I want to call a hello method. So now that will work properly. That will work. So that's a multi-level. Right? It's a multi-level. Look, it's hello from JDK, IDK, and all the things we are able to access the property of encapsulation. We are able to access the property of this particular IDK. Right? You're getting my point. So that's a multi-level inheritance. Multi-level inheritance is happening here. Multi-level inheritance. Multi-label inheritance is happening here. Awesome here, awesome. I hope this is making sense to everybody, right? Now here we have few MCQ which I want that you should solve by yourself, and I'll expect the answer in the chat if you can give, guys. That really lot. So read them carefully, by which you will evaluate yourself. If you're not able to answer these questions, go and watch the video again. Okay, these things. And after that you have this small practice. These will help a lot in the like in terms of online assessment and in terms of technical interview also. So try to figure out the answer of these things based on your lecture. Bye bye to all. Yeah, see you in the next video. Thanks for watching this entire video. But remember, if you haven't watched the previous video, go here. And those want to practice really good in DSA or the problem solving, they can solve 150 not out questions from Prep Insta. Okay, you can go here and you can search all these questions. These will help you a lot in logic building. Okay, perfect, yeah. Awesome, yeah. So see you in the next video. Till then, take care. Bye bye. Wrapping up.